Hello everyone. So far we studied that the Coulomb law between two charges Q1 and Q2, and the expression of the force is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. But if it is in a medium, then it will be 1 by 4 pi kappa epsilon naught Q1 Q2 by R square. Now, what is the expression of the Coulomb's law in vector form? So let us consider the two charges Q1 and Q2, and here is the coordinate system and origin. So that Q1 is at a distance, let us say this is R1 vector. This is R1 vector, and the charge Q2 is at a distance R2 vector from the origin. So the distance between or the separation between these two charges will be R vector is equal to simply R2 vector minus R1 vector. So let us take two points. These charges are point A and this point is B. Then obviously this AB vector, which is equal to R vector, which is equal to R2 vector minus R1 vector, we can write it as R1 vector, right? So the force between these two charges Q1 and Q2 will be, let us say, the situation is Q1 Q2 is greater than 0. Q1 and Q2 is greater than 0. That means Q1 is positive. Q1 can be positive and Q2 is also positive, or Q1 is negative and Q2 is also negative. Then only Q1 Q2, the multiplication of Q1 Q2 will be positive. So that means they are of same polarity. They will simply repel each other. So the force will be in this direction. Force will be in this direction. This force is called force Q2 due to charge Q1. So if I say it is Q1 charge, it's suffix 1, and Q2 charge is suffix 2. And obviously, this will be due to 1 into. So we will take force in this way, that due to 1 into. The same way, the force will be along this direction, repulsive in nature. So the direction of force is in this direction, and the force will be due to 2 in 1. Due to 2 in 1. Right. So, according to Coulomb's law, force Coulomb force acting on Q1 due to Q2 is, so due to Q2. So obviously force due to 2 in 1. Force due to 2 in 1. Right. So this way. So is equal to 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught Q1 Q2 by R square and R1 2 cap. This R1 2 cap is unit vector. So in the same way, Coulomb force acting on the Coulomb force acting on Q2 due to Q1 will be force due to 1 into vector, it will be simply 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught Q1 Q2 by R 1 square, which is nothing but R 1 square, or R square. It will be simply R square R 1 cap, right? Here we know we know R12 cap is equal to R12 vector by modulus of R12 vector, which is equal to R12 vector by R, magnitude of the vector. So if we write in terms of vector form, it will be if 1 2 vector is equal to 1 by 4 pi epsilon naught q1 q2 by r square q1 q2 by r cube r1 2 vector. So this is the expression of force when we will write in terms of vector form. And the force, similarly, force due to 2 in 1 will be 1 by 4 pi epsilon naught q1 q2 by r cube r1 to r sorry r21 vector. It will be also, this is r21 f21 vector. So this is the expression of force when we'll write in terms of vector, not unit vector, right? Now the second situation when now second situation is when q1 q2 is less than 0. If q1 q2 is less than 0, then obviously the force between these two charges q1 and q2, they are separated by distance r vector, and here is r1 vector and here is r1 vector, and this is r2 vector. So the force, so as q1 q2 is less than 0, that means q1 can be positive, then q2 will be negative, or second situation is q1 is negative, then q2 is positive. Then the direction of force will be, so they are of opposite polarity, so they will attract each other. So this way the direction of force will be in this direction. So this is the force due to 1 in 2, and the direction of force will be in this direction. Force due to 2 in 1, right? So this is the direction of force between these two charges. So from here it is clear that r12 vector is equal to negative of r21 vector. Then also force due to 2 in 1 vector is equal to negative of force due to 1 in 2, right? So this will be the situation when they are of opposite polarity. So now force between multiple charges, superposition principle. So if we have more than two charge q1 q2 q3 q1 q2 q3 qnth, so if we have multiple charges q1 q2 q3 qnth number of charges, then what will happen? What is the expression of force? So now, so let us say the position, the separation between these two charges q1 and q2 is r12 cap, r12 cap, and the separation between this q1 and q3 is equal to r13 cap. And in the same way, the separation between the charges q1 and qn is equal to r1n cap. So the force acting on q1, so the force acting on this charge q1 due to all other charges, what is the expression of force? So we'll write force on q1 due to all other charges will be, so force F1 vector. So force on the charge Q1, on the charge Q1. So due to the all other charges, so due to Q2, due to Q3, due to Qnth. So all other charges will be is equal to, so it will be equal to force due to 2 in 1, due to 2 in 1 in this way. So plus force due to 3 in 1 plus force due to 4 in 1 plus dot plus force due to nth in 1, right? So this is the force. So we will go this way. We will go this way due to 2 in 1, due to 3 in 1, due to 4 in 1, in the same way due to nth in 1, right? So 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 we'll calculate individually what is the expression of force due to this, due to 2 in 1, right? So the force A vector, so the force A vector due to 2 in 1 already we know. So the expression of force is equal to 1 by 4 pi epsilon naught, which is we will consider it as K into Q1 Q2 by R due to 2 in 1 square R to R1 to cap, right? Similarly, 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 force due to 3 in 1 is equal to the 1 by 4 pi epsilon naught is K Q1 Q2, sorry, Q1 Q3 by R13 square R13 cap, right? Then dot force due to nth in 1 is equal to constant K, which is 1 by 4 pi epsilon naught Q1 Q nth by R1 n square R1 n cap, where K is 1 by 4 pi epsilon naught, where K is 1 by 4 pi epsilon naught, right? So force F1 vector is equal to, so we can write F1 vector is equal to constant K, which is 1 by 4 pi epsilon naught into Q1 Q2 by R12 square R12 cap plus Q1. So this is F1 vector, Q1 Q3 by R13 square R13 cap plus dot plus Q1 Qn by R1n square R1n cap. Similarly, we can write the expression of force F2 vector. That means force acting on the charge Q2 due to all other charges Q1, Q3, Qn, and so on and so forth. Okay. So what is the expression of force acting on Q2? Now the force F2 vector is equal to this K into Q2 Q1 by R21 square R21 cap plus Q2 Q3 by R23 square into R23 cap plus dot plus Q2 Qn by R1 R2n. This is Q2 Qn by R2n square R2n cap, right? So this is the expression of force acting on the charge Q2, and this is the expression of force acting on charge Q1. So this way we can write the the force between multiple charges Q1, Q2, Q3, Q4, Qn dot Qnth number of charges, right?